Alright, so just going to finish off the graph from the last example. Just kind of summarized all the things we found for the function x squared minus 2x minus 3. We found our y-intercept, x-intercepts, axis of symmetry, vertex. We found that it opens up. There's a point symmetric to the y-intercept and the domain and range. And so we're going to just plot all this stuff, except I guess the domain and range, but everything else gets plotted on the graph, and then the domain and range you'll be able to see from the graph when we're done. Okay, so just going through this again, making each grid mark equal to 1 unit. The y-intercept is at -3, so 1, 2, 3. The x-intercept is at, or intercepts are at 3, 1, 2, 3, and -1. The axis of symmetry is at +1. So that's going to run down here. Let's see. The vertex is at 1, -4. So here's 1, 1, 2, 3, 4. This graph is going to open up. You can kind of see that developing already. The point symmetric to the y-intercept is at 2, -3. Remember that the distance here from the y-intercept to the axis of symmetry is 1, and so you have to go 1 to the other side to get the symmetric point, and that's where the 2 comes from. Okay, so that's doubling the axis of symmetry value. And I think that's everything. And so you can kind of see what this graph will look like. I'll just sketch the curve in. Something like that. And there it is. Looks like a pretty decent graph. One thing I would recommend is also putting the ordered pair on each of those points. So we know that this vertex is 1, -4. It is a minimum value because the graph opens up. The symmetric point was 2, -3, and the x-intercept here was over at 3, 0. On this side I have what's that, 0, -3, and here this would be -1, 0, and that should give me all 5 of my points, and a pretty decent graph. Okay, so just last thing here to summarize this section. We looked at 2 different formulas. We looked at, better zoom this out. We looked at the vertex form and the standard form, and a whole bunch of features of the graph. Going right down the line here, you'll see the formula for each one. The vertex form has the A, the H, and the K. The standard form has the A, B, and the C in it. Okay. To find the y-intercept, in each case you just plug a 0 in for x. And for the vertex form, the y-intercept is whatever you would get out after doing that. In the standard form, when you do that, you always just get the c out, so you just use 0, c there. For the x-intercept, we plug the 0 in on the left side, on the f of x side of the equation, and then solve for x. Okay. When you're working in vertex form, the easiest way to solve for x is just to isolate this square factor and to use the square root property. When using the standard form, the best way to solve for x could be a variety of things, but I would focus either on the factoring technique or the quadratic formula, whichever one seems easier to the problem. The axis of symmetry, remember here the axis of symmetry runs through the vertex, so it's the x value of the vertex, which is the h. And in the standard form, it's that -b/2a formula that we got from taking the average of the x-intercepts. The vertex in the vertex form is the h and the k. That's where it gets its name, because the h and the k show up. That's the horizontal shift and the vertical shift of the parabola. In the standard form, the vertex comes from the negative b over 2a, and this is what you get when you plug that back into the function. The point symmetric to the y-intercept, well, that one, remember, is always double the h value, and then we use for the y value the original y-intercept. Over here, you double the h value. Well, the h value in the standard form is at negative b over 2a, and then you use the c from the y-intercept. Domain is going to be all real numbers in both cases in any quadratic function. And then the range is kind of interesting because the range is different whether the graph opens up or down. So if the a value is positive, you get an opening up graph. That means it starts at the minimum value and goes up to infinity, but the minimum value is the y value of the vertex. That's your k. In the standard form, again, the y value of the vertex is your f of negative b over 2a. It's what you get when you plug negative b over 2a back into the function. That goes as your minimum, and it goes up to infinity. If indeed the graph opens down, that would be an a value less than 0, or negative. Then the graph starts at negative infinity, goes up to k, the maximum point at the vertex. And here the negative infinity, and then this would be the k, equivalent to the k value. It's what you get when you put in the negative b over 2a back to the original function. Okay, so there you have it. That's a pretty decent summary of the two different forms of a quadratic function and how to find the different features of each of their graphs.